Alright, welcome back to Algebra, Chapter 3, Section 7, Absolute Value Functions. Alright, so absolute value functions include an absolute value expression. So like this, the parent function of absolute value function is y equals absolute value of x, or we could also write that as f of x equals the absolute value of x. Okay, so if we want to complete this table here, if x is -2, I plug in -2 over here. The absolute value of that is +2. So replace this with +2. Absolute value of 1 is +1. Absolute value of 0 is 0. Absolute value of 1 is also +1, and of 2 is also +2. So you'll notice we have +2, 1, 0. 1, 2. Okay, so this is going down, down, and then back up again. So the graph of an absolute value function isn't a line, but it's a V-shaped graph like this. So as long as it's positive, it keeps going down, and then here we call this the vertex, where it goes back up again. Okay, so this is the graph of the parent function f of x equals the absolute value of x. Now, in the previous lesson, we looked at a function like this. I gave you a little cheat sheet to write down and broke down every part. This is every transformation that we've looked at so far. So we started here, said this moves us left 5 units because minus -h, right? That's what gives us the positive here, x minus h. Everything inside the parentheses is the horizontal change. Everything outside is the vertical change. If we're multiplying inside the parentheses, we need to flip that. And since that makes it a fraction, makes it less than 1, it's shrinking. It shrinks by a scale factor of 1/4. If this was 1/4 in the parentheses, we change it to 4, and it would stretch. The negative reflects across the y-axis because we're doing horizontal change, left and right, and that means it's going across the y-axis. Outside the parentheses, the next thing we would do is the vertical change, multiplication here. This we take at face value, stretched by a scale factor of 2. If it's negative, that means it's reflected across the x-axis. And then the last thing we would do is the vertical change, moving up or down. In this case, +3 moves up 3 units. Now, there is an order to this. Okay, it doesn't quite follow totally the order of operations. We start with this move, the horizontal move. So this is first right here. First. Okay, and then we stay inside the parentheses. This is next. This is second right here. 2, 3. This is outside the parentheses. This is the next step, 4, 5, and this is last. The last thing we would do is move it up or down. Okay, so there's the order for the transformations. Now, if we're looking at an absolute value, notice that this looks very similar. Okay, what we changed, we put an absolute value right here, but all the operations do the same thing. Okay, and again, the order is the same. This is first. Then we do the multiplication starting in the absolute value bars, moving out. And then lastly, we move vertically up or down. Okay. So same procedure here. Put this in your notes or make an index card adding all the different transformations for an absolute value. Now, in absolute value functions, if you write it in this form, this is called the vertex form. Okay, we've got a multiplication outside the absolute value. No multiplication in here. We've got x minus a number and then plus something out here. The vertex can be found as h and k. Now note that this is minus h. So if you have an example like g of x is equal to x minus 2 plus 5, the vertex is 2, not -2. and 5. If you had h of x is equal to x plus 3 minus 4, the vertex is negative 3 and negative 4, because it's the opposite of this sign right here. All right. Here we have the parent function, y equals x. Now, if we did plus 2, all right, I'll write a new one for this. Y equals absolute value of x plus 2. Okay, there's nothing to do, no transformation inside the absolute value, nothing in front, just a plus 2. That means we take this and we move it up vertically. So we move it up to right here. Oh, there we go. That's a vertical translation. If I have y equals x minus 2 plus 1, that is, first we do this horizontal change. Remember, minus positive 2, so that moves to the right, and then up 1. Okay, so that's the transformation. We start here, and then we move. If we have y equals, let's say, 3 times x plus 2 minus 1. Now let's start with moving just the vertex, all right? We would move this vertex plus 2. Plus 2, yeah, moves to the left, right? Because the h here is negative 2. And now the next thing I would do is stretch this by 3. So that's a vertical stretch where the parent function is up 1 over 1 and up 1 over 1, right? Would have looked like this. I'm going to stretch that vertically, so going this way, by a factor of 3. So instead of going up 1 over 1, I'm going up 3 over 1. Up 3 over 1. Okay, so now my function looks like this. Up 3 over 1. And now I can take that and I can move it negative 1. So now I'm moving that down 1. So we're down here with the vertex. Okay. All right. And finally, we might have a situation where there's a multiplication of the x inside the absolute value, like this right here. It's important for that situation that we do it in the right order. Okay, so if we have f of x is x plus 2 minus 3, right? Plus 2 means negative 2 as far as we're moving the vertex, so negative 2 minus 3. So the vertex is at negative 2, negative 3. So there it is, negative 2, negative 3. And now, this one is the same as that one, except it has a horizontal stretch of 1/2, right? So it's stretched horizontally by 1/2, because inside the parentheses or inside the absolute value bar, we would flip that. So a stretch of 1/2 horizontally means this way, so it goes half the distance back to the x-axis. 1/2 horizontal stretch. A shrink, sorry. If it's a half, it's a shrink. Okay, so back towards the y-axis. All right, and that's all we're going to do today. Woo!